E ok să începem, Cristi? E ok? Începem? Sure. Bună ziua! Pentru cine nu m-a văzut ieri sau nu mă cunoaște încă, mă numesc Andrei Nițu Exarcu și sunt Systems Engineer la Fortinet. Ieri am avut un, n-aș putea spune neapărat deep dive, dar am vorbit destul de direct aplicat pe anumite produse și anumite situații și anumite use case-uri în mediile industriale. Astăzi, acum la plenary, o să fac așa mai mult o poveste. O idee generală de care a fost atitudinea noastră și direcția noastră când vine vorba de toate aceste buzzwords, cum au fost în ultimii ani, SD-WAN, SD-Brand și, evident, buzzword de FortiSASE, pe care le știți bine, probabil, pentru că am văzut în agenda că toată lumea a vorbit despre SASE. Bun. Dar la noi, de la bun început, a fost ideea unei evoluții naturale. Și, sincer, o să mai repet chestia asta de-a lungul prezentării, pentru că mi se pare destul de interesant și destul de fascinant cum s-au dezvoltat lucrurile în cadrul Fortinetului. Dar pentru început, povestea clasică de SD-WAN, pe care cel mai probabil o știți. Acum, SD-WAN-ul la noi, în România mai ales, a avut o evoluție, n-aș putea spune neapărat... Oh, scuze. Sorry. E cineva care nu știe engleză? Nu poate să înțeleagă engleză? Avem persoane în public care nu știu română, nu vorbesc română și m-au rugat să vorbesc în engleză. Ar fi în regulă pentru voi? Da? Cool. Sorry. Yeah, so I'll switch to English so everybody can understand. So like I was saying, we're going to have a little talk about the journey, our journey through all these little products, all these little technologies rather than products, because that's the short and gist of it. We don't really sell products as much as solutions and technologies. And when we look at what started it all, which was the SD-WAN, what I was saying is that in the west side of the world, the evolution of the SD-WAN was sort of kind of pushed by the need to relinquish MPLS, because MPLS in the west is really, really expensive and hard to maintain and not all that flexible. So the idea was, how can we remove MPLS but still maintain the same amount of viability within our connected branches and connected distributed network. So the idea came, okay, let's do sort of a smart hub and spoke tunneling, a smart connection between our branches and our HQs, where the traffic would dynamically go through the best possible path. And this jump-started the idea of the SD-WAN. Now in Romania, of course, MPLS won in the eastern side of Europe. MPLS is not all that expensive, but one advantage that we have is that our networks, generally speaking, are very resilient, very powerful, which allows SD-WAN for us not necessarily be a technology that enables us in the face of failure, but rather that boosts our productivity, boosts our traffic, because we always know that all our applications go to the best possible way and we can maximize all the infrastructure that we have. And a long time ago, 2014 something, when first we talked about SD-WAN, a lot of people did something called SD-WAN. Everybody wanted to be there in the forefront and say we do SD-WAN, but there wasn't a real clear distinction on what SD-WAN was. And on our side, at one point we thought, okay, well, our FortiGates, our firewalls, can balance between two internet connections, so let's call that SD-WAN. And literally, from one firmware to another, we changed the name of the functionality between one link load balancing in one SD-WAN. But of course, that was more or less a marketing gimmick, because the idea was simply, okay, let's balance the traffic with some basic parameters, through some basic stuff like, I don't know, round robin, stuff that ECMP as a feature already does. But then we started to evolve and we started to create more and more and develop this technology and try to achieve all of the points that SD-WAN should achieve, that SD-WAN should be. And I am pretty happy to say that up to this point where we are now, we pretty much check all the boxes when it comes to SD-WAN. Real SD-WAN. Our infrastructure, our SD-WAN infrastructure, is a dynamic one, an evolving one. The applications are steered dynamically. Our firewalls can detect them and identify very granularly everything that needs to flow through each path and direct that traffic through the best possible path, and at the same time be resilient, heal itself, and have a centralized management where you can control, manage everything. Now I will go a little bit further on how basically we achieve that, but I will not deep dive technically into it, because I really want to talk about some other technologies. But the idea was simple. We started this from a FortiGate perspective, from one perspective, the FortiOS, and we built on top of that. And we started with SD-WAN, and then we got to the SD branch, which was the idea to onboard switches and wireless and the infrastructure in each branch into this distributed control network. Software define everything. But then what do we do with the endpoints, with our users who might not be at the branch side? Okay, let's introduce them as well into this SD-WAN architecture and have SD everything. And in the end, reach the point where we are resilient, where our applications are safe. We know they will always flow through the best possible path. So what is our next goal? To make sure that the experience of a user is an ideal one. So at the end of this journey right now is the idea of digital experience monitoring, of something that can measure how our applications are received by either our employees or our customers, anywhere they might be, and measure if that is a good experience. For example, if we have something like software development, we sell an application that really needs to run well. Does that application run well within our own environment? Probably yes, because it's directly connected to our servers where that application resides. But does it run well in India? Does it run well in America? So we are at a point where we need to consider that as well. We don't want to just sell a functionality, we want to sell a good experience. So how do we achieve all of these things? Well, it's not a clear-cut journey. It's not something that, okay, you need this, and then you will need this, and then you will need this. Because honestly, that's not really a scalable mentality. You need what is best for you at the moment. So always, an SD-WAN, from our perspective, is an evolution through the steps that you feel are best for you. Maybe you need SD branch, maybe you need remote access, maybe you need security within the data center. All of these combine and create your journey to a real converged SD-WAN solution. Now, moving on further, deeper into the actual technicalities of it, I did mention that everything started with the FortiOS, our FortiGate, our firewall. And it is still that idea. Everything is managed by our firewall, meaning one OS, one device that can scale and that controls everything. One interesting thing here, like a sort of a side thing that I want to mention because I really think it's cool, is I did say that we started at something very basic many years ago. And we built and built and built and built to what it has become basically a leader in the SD-WAN market. And this is because our development has been the primary focus of our funding, of our budgeting. So in Fortinet, we have at this moment around more than 900 patents. That is how we want to grow, always. Create, develop, never sleep on anything. Always try to do better. Always try to find new functionalities. Always try to discover how we can do better. And we have proof of this through this many patents that Fortinet has submitted. Great. So now let's look a little bit, just a few minutes, at what such an architecture looks like. So first of all, we have the SD-WAN part that I've already talked about. And what SD-WAN is, like I said, an infrastructure connecting all your branches, all your HQs, to direct your traffic and the applications and employees' productivity traffic in the best possible way to make sure that no application ever has latency issues or packet loss issues. Everything can be scaled, everything can be healed. But the big point of having all of this evolve naturally from our firewall is that everything is natively secured. And that is the big point, and I will repeat this later on in a few more slides. our SD-WAN is a secure SD-WAN. In fact, from when we first started developing the SD-WAN, we like to say that we had not software-defined WAN, but security-driven WAN. Of course, that marketing didn't stick, but the point was simple. We bring infrastructure, we bring all this connectivity with security from the get-go. We don't apply security as an afterthought, as an add-on. Everything is secure from the get-go. So everything revolves around security. Our infrastructure, our SD-WAN is not built by routers, it's built by firewalls, by next-generation firewalls at that. And the SD branch side of things, again, the same idea. Let's extend our security to the branches. Now, for who is not aware or has not had experience with Fortinet before, the idea of the SD branch is that our Forti switches, our Forti APs onboard directly on our firewalls, meaning that once you stick a Forti switch or a Forti AP into the FortiGate, our firewalls, then that switch, that AP, become part of the FortiGate. Effectively, one single logical machine from which we control everything, routing, switching, wireless. But it's not just about the ease of management. It's not just about having a very plug-and-play solution. It's about extending the firewall security awareness directly to the layer 2. The firewall controls the switch, which means the firewall sees what the switch sees. The firewall controls the AP, which means the firewall sees what the AP sees. And we extend that security with automation, with centralized management, with deployment to the layer 2. So we have this entire infrastructure from the layer 2, switching wireless, all the way up to the WAN side of things, controlled and secured by a single solution type, the FortiOS, our FortiGate, which establishes the SD-WAN and controls everything that is on that branch. Now, I did say that we evolved from something very basic to what is a leader. This wasn't me saying that Fortinet is a leader, oh, that's great. This is Gartner saying that Fortinet, first of all, has been a leader in network security for the last 12 years. Now, that is something. But more than this, Fortinet is a leader in SD-WAN. And this is actually pretty interesting because I have had a discussion these days with somebody who told me, yeah, many years ago we looked at another vendor mostly because we thought Fortinet wasn't such a big deal in SD-WAN at the time. And we have never considered Fortinet for SD-WAN because as we thought, Fortinet is not that big of a player in SD-WAN. And I was like, well, have you looked at the Gartner in 2022 or 2021 at that? We have been a leader in SD-WAN for quite a few years. And more than this, more than a leader in SD-WAN, and this is the best part, we have been a leader in security-sensitive WAN use case. Because again, we don't want just to do SD-WAN, we do secure SD-WAN. Everything is achieved by our secure solutions, which means everything is secured by default. Now this is achieved, of course, with our FortiGuard services. FortiGuard services is our bread and butter of threat intelligence. It is our service that each FortiGate and all of our products can access, and the intelligence that allows them to see the traffic, to understand the traffic, to secure the traffic. Everything that you see here is achieved by various Fortinet solutions. Now, some of them, like deception technology or IOC, these are done by dedicated products, not by the FortiGate itself. But things like IPS, application control, antivirus, all of these are by default on your FortiGate machines. The FortiGate that again established the SD-WAN, established the SD branch. So, what do we do next? We have established a secure infrastructure, WAN side, LAN side. But what about our users? Are our users secure? When they're in the company network, sure, we can sort of say they're secured. Although, I mean, there's this entire movement about ZTNA. People have been talking about ZTNA, ZTA, Zero Trust architecture, Zero Trust mindset for the past few years, where even if they are in your network, you should never assume that they are safe. And that's a big point. So we need to extend this visibility that we've achieved, this security, down to the endpoint side. But not just when the endpoint is on your network, of course, because as we know, remote working is an important aspect in our life post-pandemic. Now, I won't debate at this point. There have been a lot of talks in the last year. Should we continue remote working? Should we eliminate remote working? There have been companies that have abandoned their physical offices altogether and do full remote work by default. There are some companies that have rejected continued remote working and have forced employees to come back to the office. But even in that case, there are a myriad of instances where the employees must work remotely, must be secured, must have access to company details. So, how is that achieved traditionally? Of course, through a VPN connected to our company network, which is okay if everything is predictable. If the number of employees will not change, if that firewall is capable of sustaining all that traffic, if there is no interruption, if the company's laptops are completely forced to always use the VPN, a lot of ifs. But in this day and age, flexibility has become quite an important thing. So this architecture is becoming less and less easy to manage because of its lack of flexibility. So we need to consider what happens when our employee is not accessing the internet. Can they connect to with a laptop that has access to the internet, unscanned, unsecured, and put that laptop in the company network? Because at that point you have a problem. If there is any chance that the employee can bring an insecure, an untested device into the company network, then there is a chance that that will be used as a breach point. And I will not talk about the dangers of the internet. We are all here because we understand what cybersecurity means. We are all here because we understand the dangers of the internet. But what's important is how we move on. How do we secure a device that might not always be in the company network, that might not always be in the VPN, and how do we secure employees that do not want to be inside the VPN? Because we have had these discussions before, and everybody keeps saying, well, tough luck when the employee doesn't want something, they will not get it. Tough luck, you will have to, do what the company tells you to do. And every time I've had this, most of the time that I've had these discussions, eventually there is an exception made, because eventually there is an employee that tries hard enough, that has enough friends, that will ask for their laptops to be insecure. That will ask for their personal laptops to be allowed in the company network. That will ask and receive. And at that point, we have to figure out how do we secure without killing productivity. And the biggest issue at that point is shadow IT. The idea that the administrator does not see what is going on, does not see everything. So we need a way to try and see everything, to try to maintain a high enough level of security, a high enough level of zero trust attitude without damaging the productivity of the employee. So, in comes our idea of ZTNA, Zero Trust Network Access. Now, Zero Trust Network Access is based on the idea of Zero Trust Access as a mindset, but is in fact a technology that we have developed, a technology that can be done between our FortiGates, again, everything centralized in a single platform, and our endpoint agents, which are called FortiClients. So let's compare why we see ZTNA as a sort of a new age VPN. Not replacing the VPN, but rather as a different kind of remote access. Now, the VPN, traditionally, is a one-time tunnel generation. Like, the employee wants to connect to the network, wants to use some internal application, so they will create a tunnel, or if it's an always up tunnel, okay, that tunnel is always up. But an important aspect of that tunnel is that by virtue of how the tunneling works, checks for the tunnel are done at the start of the tunnel. Meaning, we check if the station is secured, we check if there is a security posture that needs to be verified, and then if everything is okay, the tunnel is up. But what happened afterwards? What happens if that device, that endpoint, is hijacked or compromised? Is the tunnel still up? Most likely, yeah. And sure, we might have some checks inside the network. We might try to detect a breach attempt there. But the tunnel is still there, and it is viewable within the operating system, because the VPN tunnel is a virtual adapter. If a virus is on my endpoint and my endpoint is connected to a VPN to our company network, then that virus will see the VPN and will try to hijack it. So what we do with the ZTNA? Let's look at the simple architecture. We have our FortiGate. This is our FortiGate. Up there is the management plane for our agents, our endpoint agents. Up there, it's called a FortiClient EMS, Endpoint Management Server. The idea is for the endpoint management server to control our fleet of FortiClients. The FortiClients are installed on each company network, on each company device, sorry, and the EMS will see and communicate with that and manage our entire fleet of FortiClients. What happens when a FortiClient is registered to the EMS, so the agent itself on our company laptops, the EMS will verify it and push the configuration, push stuff like apply web filtering in such a way, apply antivirus in such a way, apply application control in such a way, because our endpoint agent is a security agent. Our endpoint agent can do antivirus, can do application control, can do web filtering. Important aspects for when the client is outside the company network and not behind a FortiGate. But more than that, the EMS does two other very important things. First of all, it generates a unique certificate and pushes that certificate to the client, which means that at that point, this laptop here can uniquely identify itself as a hardware device. And more than this, it pushes what we call ZTNA profiles and ZTNA tags. Now, what those are is the EMS telling the FortiClient, check your device. Is your device vulnerable? Is your device up to date? Does it have the latest antivirus signatures? Does it have an antivirus period? And even as granular as look for a registry key with this value. Is it there? Look for a file with this name. Is it there? Look for a process that is running. Is that process running? And if those things are checked, that information is sent back to the EMS, which then pushes it to the FortiGate through our idea of a security fabric where all of our devices communicate with each other. And the big thing now is at this point, our FortiGate is aware of everything that is going on in our company laptops. Is a company laptop vulnerable? The FortiGate knows it. Is a company laptop with its antivirus down? The FortiGate knows it. More than this, the FortiGate receives the certificates that the EMS pushed to the laptops. So the FortiGate is aware of a way to uniquely identify all our company laptops. Bearing that in mind, now we have an employee here working remotely or within the company network. Mind you, this is applicable by anywhere, work from anywhere, either office or remote. And the employee wants to access an internal application or internal files, like they double-click share on the desktop. That should lead to a company's internal file share, whatever. Point is, if there is no VPN that is established between that client and the FortiGate, then at that point, that action will not work traditionally because the employee is not within the network, logically. But what happens is that the FortiClient has been instructed that for certain resources in our networks, the FortiClient will establish a connection to the FortiGate and request access. And when that access is being requested, the FortiGate starts to check. Are you who you say you are? Give me your device certificate. Is the laptop uniquely identified and is it valid? Cool. Are you as a user who you say you are? Give me your credentials. And optionally, but very highly recommended, give me your multi-factor authentication. I will come back to this in a few more minutes, but very important. Next, the most important thing, validate security posture. Are you okay as a device? Are you vulnerable? Are your updates up to date? Are you running the latest Windows? Is your antivirus up? Is a registry key with a certain value in your system? Is a process running? A myriad of things that you can configure can be checked at this point. And only if everything is okay, then the FortiGate will create a secure microtunnel, a TLS encrypted microtunnel between the FortiClient and the FortiGate, and through that tunnel, proxy the access to the resources that the client wants to access, the employee wants to access. Now here's the kicker. For each application session, there's a different, separate, isolated TLS tunnel, which means that if some by god-awful reason, somehow, somebody manages to crack the session key for one of these tunnels, all the other sessions are still protected because they are encrypted by a separate encryption domain with separate session keys. So everything is isolated, everything is continuously checked. What does continuously checked means? If at any moment this laptop becomes vulnerable, if the antivirus is torn down by an attack, by a breach, that information is shared by the Forti client to the EMS, by the EMS to the FortiGate, and within seconds the FortiGate will not only block access of that Forti client to the internal network, it will sever all the TLS connections, meaning the client will be completely isolated and incapable of attacking our internal network because they will be outside of that network. They will be completely isolated. And through this, we have what we truly can recognize as a zero trust approach. We only allow that employee access to our company resources if they are safe. And that safety check is done continuously, permanently, all the time, whether they are within our network or outside our network. Now, if this happens, mind you, because I have had this question, the connections between the Forti client and the FortiGate are done, are completely severed. Yes, but the connection between the EMS and the Forti client is still up because that is just a management connection, which means that in case our employees are compromised, our laptops are compromised, we can still check them. We can still order remote antivirus scans. We can still decide if we can troubleshoot that, if we should save that, what is going on that station. We still have awareness of what is going on. We simply deny them access to anything that they could attack. All of this is done through FortiOS. Again, I will repeat this many times more, but the FortiOS is at the heart of everything, the FortiGate, which also means that all we need to do to achieve this ZTNA tunneling is the FortiGate and the Forti client. So there is no additional licensing. This is mostly because we view ZTNA as a natural, necessary functionality. We don't view it as something that you should pay for. It is something that you get as a natural evolution of the firewall. So if you can do VPN, then you can do ZTNA. All you need is the FortiGate and the Forti client. Ideally, a two-factor solution as well. Now, I did mention this yesterday, and I did say yesterday that I have always mentioned this because I just find it gorgeous, but there has been a study in the western side of, North America actually, regarding phishing attempts and regarding employee behavior in phishing attacks. You know that a lot of time you have all these campaigns where you send fake phishing emails, fake phishing attacks to your employees and try to check what is going on, how your employees behave. So basically in this study, they have they have noted down that 7% of employees are compulsive phishing email clickers. The kicker here is that compulsive phishing email clicker doesn't mean that those 7% of employees click on a phishing email. No, compulsive phishing email clickers is that those 7% employees have never missed a phishing email attack. They have clicked on each one phishing attack. They have not missed one. So there are 7% of people in the employees of those studies that will click on everything, that will download everything, that will not care. Now realistically, okay, we have security-aware employees. Our employees are smart, our employees are careful, sure. But statistically speaking, eventually a phishing attack will go through. Eventually, somebody will click on a phishing link and they will have their password stolen because it is damn easy at this point to create a realistic phishing email. We have ChatGPT that can create stupidly legitimate looking emails. And all you need is an email like, here is your Netflix receipt, your invoice, you have to pay $50. I don't have any Netflix account, doesn't matter, you have to pay $50. If you don't want to pay $50, click on this link to sign into your account so you can reject this payment. And obviously at least one person will eventually click on that. So, two-factor authentication is really not that much of a nice to have anymore as much as a need to have. Okay. Moving on to the kicker of these days, really, because again, I repeat, I saw that everybody is talking about SASE. We do SASE, obviously. Everybody does SASE. What's interesting, though, is, from my perspective, is that SASE again has been developed in-house as a natural evolution of our network technology. So again, we have not bought some other technologies and tried to integrate it. We have developed SASE using the technologies that we have developed and we have grown over these last many, many years. So FortiSASE is, as I've said, FortiOS centric. Everything is FortiOS centric. Everything has the same level of security. So FortiSASE tries to achieve that security, that FortiGate security, that FortiOS security for everyone that might not be on the network or might be on the network, or we might not want to load our FortiGate with it, for example. But the pillars of what the FortiSASE wants to achieve is simple. Secure access to cloud applications, secure internet access, and secure private access. So just so I don't bullshit you around, just so you see exactly what FortiSASE is, let me go to the gist of it. The simplest way to do FortiSASE. We don't have a FortiGate, or we have a FortiGate and it's very small, it's not capable of sustaining all our employees working remotely. But we have employees, and we install on those employees' laptops an agent. What is that agent? It's the FortiClient. It's our single agent. And that FortiClient connects to a VPN tunnel to our cloud. What happens in that cloud? We have the FortiOS, which is the FortiSASE, which is FortiOS based. So technically speaking, you can view FortiSASE as a firewall as a service, because we can do, at this point, the entire security suite of a FortiGate and FortiClient, but in the cloud, and licensed OPEX in the cloud natively. What happens with devices that cannot have a FortiClient installed? Now, mind you, FortiClient can be installed on laptops, on Windows, on Macs, on Linuxes, on Android, on iOSs, but let's assume that we have a device that cannot have FortiClient installed. No problem there. FortiSASE is perfectly capable of functioning by way of web proxy. So at that point, we simply point that device in the web proxy settings to use the FortiSASE cloud as a web proxy. And that setting will use geolocation URL, which means that even in the proxy mode, any device that will use the FortiSASE will connect to the nearest point of presence in our FortiSASE network and achieve the best performance. This one, though, I kind of like. So you've probably not heard of this before, but we do also have a product called the FortiExtender. Now, the FortiExtender is basically our version of the modem. It's a device that connects to the 3G, 4G, even 5G, and gives network access to, internet access to whoever is there. The main use case of the FortiExtender, traditionally, is connecting it to the FortiGate and have the FortiGate manage it as it would a FortiSwitch, because again, everything is FortiOS centric. FortiSwitch controlled by FortiGate, FortiAP controlled by FortiGate, FortiExtender as a modem controlled by FortiGate. This is really cool though, because you just get the FortiExtender out of the box, plug it in the FortiGate, and that's it. The FortiGate will have an extra network in its graphical user interface, 4G, 5G. But the FortiExtender can function standalone, and at this point we can put the FortiExtender somewhere in a small branch, like 4 people, 5 people, whatever, 10 people, sure, and have the FortiExtender directly connected to the FortiSASE. And we can give FortiSASE access to an entire small branch by way of this FortiExtender. Should.
In this scenario, the SASE, I do not see how the agent reaches the workloads which are hosted in my data center.
That are not hosted in your data center.
Are
Are
hosted in my
hosted.
They are hosted. I couldn't see I could see going to SaaS, I could see going to internet, but what if the workload is in my data center?
That is exactly what I was going to say next. No problem. So, I just talked a few minutes ago about ZTNA and what ZTNA is and how ZTNA is a technology with which we can do micro tunnels to connect our remote workers to our in-house server applications, our local data centers. Now substitute the FortiGate for, well, no, the FortiGate remains, sorry. The FortiGate remains, and this is the FortiGate that is, I don't know, in your data center, locally. Your employees, however, connect to the FortiSASE. But FortiSASE is based on the same technologies, which means that if we have a Forti client here, it is simply a Forti client that will do the exact same thing, but instead of being managed by the EMS that is here in your own data center, it is managed by FortiSASE. So all we have to do is tell FortiSASE to do the exact same thing that EMS normally does, and share that telemetry, that information to the FortiGate. And then we do the exact same thing we did before, but instead of having FortiClient, local management server for the FortiClient and FortiGate, we have FortiClient, FortiSASE, and FortiGate, which means that we can check and validate each and every one of our employee laptops, allow them access to a company resource in a ZTA approach, ZTA mindset, secure it, check it, validate it continuously, and give access to our FortiClient enabled workforce to our internal applications while their internet traffic is directed through FortiSASE. So this is an ideal use case, mind you. This will of course not work for the use case of proxy mode or thin edge because these do not have FortiClients. But if we can have all our employees running laptops that are FortiClient enabled, then in this case, traffic from the FortiClient, from our employees to our local data centers for our local apps is directly tunneled between that employee and our local apps, which means maximum throughput possible and lowest latency possible, because it doesn't go through the FortiSASE cloud. But all other traffic, internet access, direct internet access, is going through the FortiSASE, which means our FortiGates are not being taxed. They can perform, even if there are small FortiGates, even if our workforce grows exponentially, we don't have to substitute and upgrade our local FortiGates because the brunt of our employees scanning is served by the FortiSASE, which again is OpEx. Are our employees growing? Okay, we buy more FortiSASE seats. Do we have a downside? Okay, we don't buy that many FortiSASE seats at the next renewal period. So it is much scalable at that point. But, of course, what happens in those use cases where the proxy employees or the teenage employees need to access the company networks? No problem, because guess what? Everything is FortiOS based. What did we start talking about at the beginning of this presentation? Everything started with SD-WAN. So, of course, everything can end with SD-WAN. FortiSASE will establish SD-WAN connections to your FortiGate, on-premise FortiGates, and at that point, all traffic can be sent through the FortiSASE SD-WAN infrastructure to your FortiGates in your local data centers and achieve a truly comprehensive, complete solution. FortiSASE is not something that we aim to use to replace FortiGate. FortiGates are not something that should be used to replace FortiSASE. Everything is complementary. This is the ideal use case where, again, everything is scalable. We don't want to bother upgrading local FortiGates if we can use the FortiSASE to secure the FortiClients. But everything that is going on in here, from a security standpoint, can be done in FortiSASE. That's the power of FortiSASE. And that's the quick and gist of it. One last thing, one pretty interesting little tidbit, is that you'll probably see a lot of mentioning of SSE, Secure Services Edge, as opposed to SASE, Secure Access Services Edge. And we do SASE, not just SSE, because we have developed SASE as a convergence of our network prowess and our security prowess. So we are a single vendor SASE capable of doing everything from SD-WAN to SD-branch to CASB to ZTNA, but also in the cloud as SASE as a service. And this is recognized by Gartner. Again, not something that we ourselves say, but Gartner does say. From a licensing standpoint, again, FortiSASE is really easy to license because there is just one license. We license per user. We simply say, okay, I want 50 users. Okay, here have 50 FortiSASE users, and then all FortiSASE functionalities are available in that single licensing. So to conclude this presentation, my entire point throughout these past 45 minutes is that, again, we don't really try to create an SD-WAN box. We don't try to create an antivirus box. We try to create a comprehensive, full solution that can achieve all of our needs, and not just security needs, but productivity needs, networking needs, together. And everything is centralized by the FortiOS. Everything is done by the FortiOS. All the security, all the SD-WAN, all the SD branch, all the infrastructure in a single software that can be, of course, centrally managed itself, and very easy to license, very easy to scale. Any questions? No? Well then, thank you for coming. Oh, you should.
Yes, I have a quick question actually. I noticed somewhere you specified that you are using the same Fortinet everywhere.
Yes.
Isn't this, or can be this, considered too big? We have vulnerability that affects the FortiOS.
Maybe,
Three things here.
maybe he refers to the big vulnerabilities you had in the FortiOS.
Very good point. So, is it a vulnerability that we use the FortiOS everywhere because we have had some vulnerabilities? To answer your question first on the vulnerability side, mind you, those vulnerabilities have always been with older firmware options. So the moment that vulnerability was disclosed, we have already released a patch. But admittedly, that patch was built in a firmware. So that firmware had to be deployed, which meant, of course, some upgrades, some downtime, maybe some fear that it might cause problems. Which is why, for the last 706, I think, something like that, I would have to check, but it doesn't matter. In the last firmware versions, we have developed IPS on self traffic, which means the FortiGate is capable now of using its IPS engine to scan its own traffic. So in case we actually, again, see vulnerabilities, we have discovered vulnerabilities in the deep web or whatever, and we know that our FortiGates can be exploited, we don't wait for a firmware patch, we don't wait for an entire OS system, we simply tell the FortiGate, this is the vulnerability that you should look for, apply IPS to your own traffic and scan yourself. And in that way, we do virtual patching to our own FortiGates. Between that moment and until the next firmware release, of course, that vulnerability will be patched out. But until that point, from the moment we discover vulnerability, we are now capable of applying a live patch that will fix that vulnerability by having the FortiGate be a FortiGate for its own self. And also, final answer to your question, the FortiGate is our most developed product. I mean, yeah, there have been vulnerabilities, of course, but that's not something inherent to Fortinet or FortiGates. Everybody has vulnerabilities from time to time. But the brunt of all our patents is on the FortiGate side of things. I mean, if there is one OS, one device in our entire portfolio that I would like to be everywhere, it's the FortiGate. It's the most stable, most developed one. And right now, it's also the safest because, again, we can patch the moment we discover something. And that's pretty cool, I actually like that. Okay. That's it. I have been informed that we have 1 minute left, so thank you all for coming and I appreciate your presence.